Hey, on the last lesson, we talked about the idea of a significance test, which I referred to as a hypothesis test. And I just want to keep referring to it in both ways because sometimes when I'm going fast or I'm not thinking about it, I'll call it a hypothesis test, and I want you to understand that I'm talking about the same thing. Hypothesis test because we're going to have hypotheses. And I believe we talked quickly about a one-sided versus a two-sided test. A one-sided test was when we had an alternative hypothesis that was greater than, less, or less than. A two-sided test is an alternative hypothesis that is a not equals to. And we are actually going to do a test where we make the calculations, we get the p-value, and then we make the conclusions like we did in the previous lesson. But in this case, we are going to actually calculate the p-value. In the last lesson, it was given to us. And we are going to perform a one-sample z-test for proportions. So we're focusing on proportions in this lesson. So like I said before, and like I said in the last lesson, we have one-sided and two-sided tests. One-sided is that less than, greater than alternative. Two-sided is that not equals to alternative. And some words that you might see that would indicate a two-sided test would be if we are asking if it's different than the hypothesized value, or if the hypothesized value holds true. You've probably seen that in some of the questions from the practice in the last lesson. Those will indicate that we're just looking at a not equals to. We don't care if it's greater than or less than. We just want to know if it's different. And then for a one-sided test, we might see things like, is it less? Is it fewer? Is it smaller? And that's going to indicate to us we have a less than. We could see, is it greater, more, maybe exceeds, all words that would tell us we are testing to see if the alternative is greater than what we think it is. And then we have this four-step process very similar to our confidence intervals. We're first going to state our hypotheses. That's a must to state the null and alternative hypothesis. We have to identify a significance level, which we'll use this little Greek letter alpha, and more on that in a minute. We talked about showing evidence for the alternative. That is not something I'm going to necessarily hold you to here. Then we need to plan. We need to check conditions. That's going to be important. So we're going to check conditions like we did for confidence intervals. And in fact, they're going to be the same ones. And then we're going to actually make some calculations. So we have to calculate what we call a test statistic. That is a z value, which is something we've done in the past. We'll use that z value and plug that into Staplet using the normal option on Staplet, and we will calculate a p-value, which is just a probability. And then finally, we'll make a conclusion. So we talked in the last lesson about either rejecting the null hypothesis or failing to reject the null hypothesis, and then what that means. Sorry, I just put a little a when I meant O for null. And what that means when we reject is that we do have convincing evidence. And when we fail to reject, we do not have convincing evidence. And just as a reminder, much like when you're doing a confidence interval, you never say you're 95% sure. When we're doing a significance test, a hypothesis test, we are never going to say that we accept the null hypothesis. We are either going to reject it or fail to reject it. So here we're going to do an example of a one-sample z-test. That z-test indicates to us we're going to have to calculate a z-value. In order to do that, we're going to have to calculate a standard error for our null proportion. And so the formula for that is going to look something like this. And it should look familiar. It should look something like we've been doing when we built confidence intervals. We used that similar formula when we were building our margin of error for a confidence interval. And then we will use that to calculate a z. So we are going to take our sample proportion and subtract the hypothesized proportion and then divide by that standard error that we would have calculated. We'll use that value to then go ahead into Stapplet, and I will show you here, use that normal distribution option, and we will calculate an area on the normal curve. But let's go through all the steps first. So here we are talking about whether or not people watch Survivor, and the person who wrote the textbook and wrote this question says that they believe 35% of all US adults have watched Survivor, and then somebody thinks that's too high. If they think that's too high, that means they believe that it's actually less than that. So that gives us an indication of what our alternative is going to be. It's important that we note we have a random sample. And then we have this little alpha here. That's alpha, like fishy, sometimes we call it. That's our significance level of 0.05. We're going to use that to compare to our p-value to decide if our p-value is small. So let's write our hypotheses like we did in the last lesson. Null, alternative. We're talking about proportions here. We believe it's equal to 35%. And then we're testing to see if it's less than 35%. And then it's always a good idea to maybe state your significance again, just to keep that in mind. When we get to the end, we're going to compare our p-value to that number, 0.05. So this is the state. And then we are going to plan by making sure we check our conditions. We need to make sure we say that we have a random sample. And then we need to check the NP and n times 1 minus p. And we're using the null hypothesis p. So we're going to use that 0.35 here. So we're going to multiply our sample size of 200 times 0.35, and then 200 times 1 minus 0.35, which for those of you playing along at home is 0.65. And so we get 70 and 130. And hopefully you remember we want both of those to be 10 or more, and so we're good. And so now we're allowed to go ahead and do our calculations. So we need to calculate our standard error by plugging in that P0, 1 minus P0, and N. So we have 0.35 times 0.65 over 200. And this is our do process. And so we get a standard error of something close to 0.0337. That's going to help us calculate a z. For z, we're going to take our p hat, which we're going to need to calculate. So we said that 60 out of 200 watched Survivor. So p hat is 60 over 200, which is 0.3. And so when we go back to z, we're going to do 0.3 minus 0.35, our hypothesized proportion, and then divide by that standard error that we calculated. And we're going to get a z-value of negative 1.484. And if you remember from when we did normal distributions. In the middle is 0, so negative 1.484 is somewhere over here. Because we have a less than alternative, we're looking for the area to the left. So we are going to calculate the probability, that our z value is less than negative 1.484. And we're going to do that in Staplet. We're going to tell it the mean is 0. We're going to tell it we want a value to the left, and then we're going to plug that z value in. Negative 1.484. And is it mad at me? No, it's not. My area is 6.89. That's a percentage, so I'm going to change that to a decimal and make it 0.0689. That is my probability. Now I need to, this is where I said I was going to go ahead and compare that to this significance level. So I'm going to go ahead and write that down here again. And if you remember in the last lesson, I said when the p-value is small, you reject the null. Well, if the p-value is smaller than that alpha value, we reject the null. In this case, my p-value is bigger. It is not smaller. It might be small, but it's not smaller than 0.05. And so I am going to fail to reject. And that means that I do not have convincing evidence. So when I write my conclusion, I am going to say that there is not convincing evidence and you might want to fast forward to get to the end here. And we can maybe come up with a formula for writing this together in class, but basically we want to say if there is or isn't convincing evidence, we want to make sure we're stating the parameter. Is it a proportion or a mean? So in the next lesson, we'll talk about means. And then finally, you want to put the context in there. We're talking about the proportion of adults who watch Survivor, and we were comparing it to a value of 0.35, 35%. So because I want to make sure that I never make you listen to more than you need to on here, but I do want to make sure that I am thorough enough, I'm going to have you go through the steps one by yourself, and then you can check with me to see if you did it correctly. So I'd like you to state the hypotheses on your own. I'd like you to do the planning where you check the conditions. But I would like to do the calculations with you since that's the new part. So you should have practiced doing hypotheses in the last lesson. We've been checking these conditions now for a few weeks. And so let's talk about the calculation part. We have a hypothesized value of 26.4%. So that is 0.264. And we've got a random sample of 750 students, and 229 of them say they have vaped that year. So we're trying to figure out something about the percentage of students who would vape at these schools. And so after you state and plan what you're going to do on your own, and you can check with me, we are going to calculate our standard error. And so we're going to take that 0.264 and multiply it by 1 minus 0.264 and divide by 750. And so we get a standard error of something like this. We need to know what our p hat is in order to find our z value. P hat is going to be that 229 vapors divided by the 750 in the sample. And then we're going to calculate our Z value. So we're going to take our P hat, subtract, my voice cracked there, subtract our hypothesized proportion and divide by that standard error we just calculated above. And we're going to get close to 2.57. So now we need to find a probability, and I'm going to have to give something away in the plan or in the stating phase. So if you haven't already stated your hypotheses, I'm going to give something away. This is a not equals to alternative hypothesis, which makes it a two-tailed test. So when we draw our picture, we're going to have 2.57 over here, and we're going to shade into the right. We're going to have negative 2.57 over here and shade into the left. We've shaded two tails, which means we're actually going to find this area and then multiply it by 2. So we're going to find the probability that Z is greater than 2.57 and then multiply that by 2 to get our final p-value. And so in Staplet, if I go change this to 2.57, and I want to make it to the right, it's going to give me 0.51%, which is 0.0051, and we're going to multiply that by 2 to get our final p-value of 0.0102. Now our alpha value is 0.05. We're going to use 0.05 because it wasn't stated in the problem, and so typically when it's not stated, the rule of thumb is to use 0.05. And so in this case, my p-value is small compared to 0.05. And when the p-value is small, you reject the null hypothesis. And when we reject the null hypothesis, we are going to say in our conclusion, I'm getting used to this iPad, so I keep hitting things. When we conclude, we are going to say there is convincing evidence. And so much like I asked you to do the state and plan portion, I want you to try and complete this conclusion. There is convincing evidence because we rejected the null. We rejected the null because the p-value was small. And I want you to bring the context in here and try to finish the conclusion. Check it with me when you're done, and then you can go ahead and do the practice. And as ever, take your time on that, and good luck.